Uh, hello everyone. So today I am discussing about one more interesting section, that is the frequency divider, which is related to the placement. This is the important topic. Okay. So before the starting of the frequency divider circuit, this is the part 0 lecture, and here firstly I will discuss about the basic thing. Okay. I know so most of them know already about this concept, but I am discussing for that who don't have idea about that. Okay. So the time period, frequency, duty cycle, and the mode value. So this is the basic thing. So firstly I will discuss about the time period. So what are the meaning of the time period? So the time period, that it is the minimum amount of time after that the pulse is repeat itself. So here the pulse is repeat itself, means it is the minimum amount of time after that the waveform is repeat itself, that is called the time period. Here you can say this and this. So this is the time period. Okay. Now the next thing is, that is the frequency. The frequency means this is the frequency. The frequency, it is the reverse of the time period. That is the frequency is 1 by time period. Okay. So what are the meaning of the frequency? Means the waveform repeat itself how many times in per second. Means so this waveform how many times it will repeat itself per second, that is called the frequency, and frequency is 1 by time period. So time period, the SI unit is the second, you know already about. So the for frequency, that is the 1 by second, so its unit is hertz. So for frequency we measure in hertz. Okay. And the third thing is the duty cycle. What are the meaning of the duty cycle? Basically we discuss the percentage duty cycle. If we multiply the 100, percentage duty cycle is T on by T off plus T on. So this is the formula to calculate, if you want to calculate the duty cycle. Okay. So now I will tell what are the meaning of the T on and T off. Okay. So in the basic word, if I tell, the logic 1 will be represent always the T on, and the logic 0 will be represent as the T off. This is the basic definition for T on and T off. If suppose we have any pulse. Okay. So we have any pulse like that. So we have a pulse. Okay. So this pulse is repeat itself after some time, that is called the time period. So this is the time period of that. Okay. And this is the logic 1, and this is the logic 0, logic 1, logic 0. Okay. So in this case, this terminology, this is the on time. So this is the duration. In that there is a logic 1. So this is the on time. Okay. And this is the duration, in that the its value is the logic 0. So this is the off time. Okay. So this is the basic thing of the T on. So that this is the T off, T of logic, and again logic 1, this is the T on. So in one pulse there are so many T on and T off is there. So basically we will discuss the percentage duty cycle in one cycle only. In one cycle we will discuss the duty cycle. Okay. So here if I want to calculate the percentage duty cycle, so on time, that is the, so this is the 0, this is the T by 2, and this is the T. After T it will repeat itself. So percentage duty cycle we will discuss in one period. So the on time is T by 2. Okay. And T on plus T off is nothing but it is the total time period. T on plus T off, T on, T on plus T off is nothing but it is the total time period. Okay. So T on is T by 2, and T on plus T off both are same, T by 2, T by 2. So this is the T by 2 plus T by 2. If we add same thing, that is the T by 2 by T. If we cut the T by 2, that is the 1 by 2. Okay. So 1 by 2 means that is the 50% duty cycle. If we multiply 100, then this is the 50% duty cycle is there. So this is the meaning of the duty cycle. So if any waveform is repeating itself after some time period, so in one duration, in one cycle, you can calculate the duty cycle. This is the easy thing. And the next the important thing, that is the mode value. Okay, this thing we need when we discuss to make the frequency divider circuit, like f by 2, f by 3, f by 4, f by 6, like that. Okay, so here I am not discussing more thing about the mode value. This is the different thing, it is related to the sequential circuit, but here I will discuss only those part that thing we need further. Okay, suppose we have any the sequential circuit is there, that is the 3 flip flop. 3 flip flop means 3 bit storing device, so 3 bit is there. 3 flip flop means the 3 bit combination is there. Okay, I don't know about the sequential circuit, what are the sequential circuit is there. But here, so for 3 bit combination, just I am making the 0 0, just I am assuming a state diagram 0 0 0 0 1 and 0 1 0. Just here my motive is to understand the mode value. Okay, मैं यहाँ चाहता हूँ कि मोड वैल्यू का मतलब समझ ले, कि मोड वैल्यू का मतलब क्या होता है। मैं इस सिक्वेंशियल सर्किट के बारे में मेरे को आइडिया नहीं है, आई डोंट हैव आइडिया अबाउट दैट। मीन्स ये स्टेट डायग्राम कौन से सिक्वेंशियल सर्किट का है, मेरे को इसके बारे में आइडिया नहीं है। मैं मैं एक एग्जांपल एज्यूम कर लिया हूँ, ठीक है। चूंकि हेयर आई कंसीडर द थ्री बिट, मीन्स थ्री बिट इज द टोटल 8 combination is there. So here the only four state is there that is repeating itself in a loop. या ऑफ कोर्स चार स्टेट और होगा, पर उसके बारे में मेरे को पता नहीं है। होगा, मान लो कि यहाँ पे 1 1 है, और मतलब 1 1 से एक स्टेट ऐसे हम लोग मूव कर रहे हैं। तो मोड वैल्यू का बेसिकली मतलब क्या होता है, व्हाट आर द मीनिंग ऑफ द मोड वैल्यू। So mode value, it tells like that how many state it repeats itself in the loop. How many state it repeat itself in the loop, that is called the mode value. So यहाँ पर so here we can count one, uh, 1 2 3 4. So these four state repeat itself always in the loop. So here the mode value is the 4. Okay, so this thing I can understand. Okay, yeah, so you can take any state diagram, suppose 0 0, and 0 0 having the next state is 1 0, and 1 0 having next state is 1 1. After that, so that is the 0 0 here mode value. So this only three state is there that is repeating itself in a loop. So this is the mode value is the 3. Okay, so this is the basic thing. So this is the basic thing how we'll understand that this is the mode value concept. Okay, suppose just I am taking one example also to understand the duty cycle. Suppose, so we have a sequence, so we have a 2 bit. Okay, now we develop all the basic thing. So that is the foundation which we need further for a frequency divider circuit. Here I am taking the example of 2 bit, that is the 0 0, and the 0 1 and 1 1 and 1 0, just random sequence I consider. Okay, if anyone asks, so can you calculate the percentage duty cycle of the MSB bit? So this is the MSC bit, that is the B1 and B0 I am assuming. So B1 is the MSC bit, this is the MSC bit, and this is the LSA bit. So so this type of the question also asked in the interview. So this thing given to us and calculate the percentage duty cycle for MSC bit for B1. So I already told, if you want to calculate the percentage duty cycle, we need to concentrate what are the on time. On time means logic 1. So 1 and 2. On time is 2. Only 2 1 is there. And off time. Off time means off plus on. Means how many times is the 0 or how many times is 1. So 2 times is 0 and 2 times is 0. Total 4. So 2 by 4. That is the 1 by 2. Means that is the 50% duty cycle. So for any bit you can calculate. For any given sequence you can calculate the percentage duty cycle. Suppose this is the 1 1 and 0 1 0 and 1 0 and 1. So calculate the percentage duty cycle for MSC bit. So why so MSA bit? So there is the, so this is the B2, B1 and B0 MS. So this is the MSA bit. Okay, so ms is 2 times 1 and 1 times only 0. So 2 times 1 means दो बार ये ऑन होगी एंड टोटल 3 times 3 into 100%. Okay, so if we multiply like that 200 by 3, something that 6.67 like that, the 66.67%. So the 18, 18, and yeah, the 66.6. So this all thing is the basic thing. Okay, now in the next part, I will discuss the frequency divider circuit. Means how we'll design the by two circuit, by three circuit, by four circuit, by five circuit like that. Okay. So for that we'll make the different part for even integer and odd integer. Okay. Odd integer means three five different and two four six different. This is the basic thing. And okay. So thank you. In the next part I will discuss. Okay.